In this section, we're going to talk about exponential functions, graphing exponential functions, and using transformations to graph exponential functions. So let's talk about exponential functions. So we're going to deal with two concepts, exponential growth and exponential decay. So let's look at the difference. So when we're given a function, an exponential function, if our base, which in this case is 2, if the base is a value that's greater than 1, then we have exponential growth. If we have another function and our base is between 0 and 1, a fraction, then we have what's called exponential decay. That means over time, things will get smaller. So when we look real quick at just a rough sketch of exponential growth, what happens over time is that the values get larger. With exponential decay, that means your base is a number between 0 and 1, so it's a fraction. We have values that decrease over time. So when we talk about exponential growth and decay, let's look at the domain real quickly. So the domain, what are we allowed to use for exponents? Because our domain is our x value. Our domain is all real numbers because there is no restriction. For our range, look at our graph. If you notice, both graphs are above our x-axis, so they're above where y equals 0. So our domain is negative infinity to positive infinity, but our range are all the values greater than 0. So our graph would go from 0 to infinity, not including 0. Also keep in mind, if we raise a base to the 0 power, the answer is 1, whether it's a whole number or a fraction. So we know that our graph will go through the point 0, 1. And it will also go through the point 1 and whatever the base is. Because if you think about it, if I have 2 to the first power, that would be 2. If it's 1/2 to the first power, that would be 1/2. So if we're using 1 for x, the answer is just going to always be whatever the base is. So let's look at our first example. It says graph the function by making a table of coordinates. So we have f of x equals 1/3 x. So we know what our graph's going to look like. That's going to be exponential decay. So if you want to plug in some values, what I would do is make a table of values. I would plug in -1, 0, and 1, and plug that into my function. So if I have 1/3 to the negative first power, remember what that tells you to do. A negative exponent tells you to take the reciprocal, so that would be 3. So next, if I take 1/3 to the 0 power, anything raised to the 0 power is 1. And if I take the last 1/3 to the first power, remember, I'm always going to have a point with coordinates 1 and whatever the base is. And so in this case, it's 1/3. So I'm going to plot these points. So -1, 3. 0, 1. Remember, all the graphs in their parent form will go through 0, 1, and then 1 and 1/3. Okay? So what's going to happen is our graph's going to decrease, but never cross 0. That means we have what's called a horizontal asymptote at y equals 0. let's look at our next example. The first thing that I want to do is draw the parent function so that we can deal with the transformations from the parent function. So if my parent function would be f of x equaling 5 to the x. So again, I'm looking at my base. It's a number greater than 1, so I have exponential growth. Remember that I know my graph goes through the point 0, 1, and 1, and whatever my base is. If I wanted to try another value, maybe I'll use x equals -1 and plug it in. So that would give me a 1/5. So -1 and then 1/5. So my graph would look like this. So again, it will always go through the point 0, 1, the parent function, and 1 and whatever the base is. Since the base is 5, it's 1, 5. I have a horizontal asymptote at y equals 0. Notice my line doesn't pass through, it kind of hugs it and gets closer and closer as I move towards -infinity. Now let's look at the transformations. So keep in mind, when a value is affecting the x, that's going to be a horizontal shift. So we're going to have a horizontal shift in this case to the left 1 unit. And remember, when we're adding and subtracting to our function, that's a vertical shift. So since it's minus, our graph's going to shift down 2 units. So that shifts our horizontal asymptote as well. So let's look at what happens. I'm going to start with the first point. And so it says that I'm going to go down 1, and down 2, excuse me, and to the left 1. So for my 0, 1, again, I'm going to go down 2, to the left 1. And for my last point, I'm going to go down 2 and to the left 1. So now my graph would look like this. So remember, our rules for transformations work for a variety of different functions. Let's look at our next graph. So it's giving us the graph and asking us to identify the function. So let's look at each part. And so I'm going to look at each answer choice so that it'll be easier for you to select the correct answer. Okay, first of all, you notice that all of our answers have a base of 3. The minus in front doesn't mean that's our base. That has to do with our reflection. So we know our parent function is an exponential growth problem. Goes through 0, 1, 1, 3, and -1, 1/3. So this is our parent function. So look what's happened in this parent function. Our graph has flipped over. So if it's flipping over our x-axis, that's a reflection on the x-axis. So a reflection on the x-axis means that we have a negative in front of our function. So we know our function is -3 or -3 or the opposite of 3 to the x. If we had 3 to the -x, that's a reflection on the y-axis. So what would happen in that case is our graph would be going the other direction. So in this case, all that's happened is that the graph has flipped over our x-axis. So that means the answer would be the opposite of 3 raised to the x power. Our next example, very similar. So we have a base of 3. So again, we know what our parent function looks like. Our parent function goes to the point 0, 1, 1, 3, and negative 1 and 1/3. So when you look at your graphs, the first choice has the graph, since it's 3 to the x minus 1, shifting down. We know that our graph hasn't shifted down because it hasn't gone below the x-axis. So 3 to the x plus 1, since the 1 is being added to x, that deals with a horizontal shift to the left 1 unit. So if you look at our graph would have gone through 0, 1. If it's shifting to the left, then it would go through the point negative 1, 1, which it does. So that's our answer. Let's look at the other two. The first is just 3. The next one is 3 to the x. And remember, if it's 3 to the x, that means we wouldn't have had any shifting. And we know that it would go through the point 0, 1, and it doesn't go through the point 0, 1. And the last is 3 to the x plus 1. Since we're adding 1 to the function, our graph would have shifted up 1. So if it shifts up 1, our horizontal asymptote would be at y equals 1, and our graph wouldn't be hugging the x-axis. It would be above the x-axis. Also, we would have a point, since if it shifts up 1, we'd have the graph going through the point 0, 2, in which it doesn't.